In this nugget, we're going to continue to work with the Windows PowerShell pipeline. And I'm going to show you how to use a set of what I call generic commands. They're designed to work with just about anything that's in the pipeline, enabling you to sort those objects, select pieces of them, measure parts of them, and even group them together based on some simple criteria. But the real goal of this is to continue the theme of thinking about what PowerShell is doing, thinking about what each command is doing, what each command is putting into the pipeline, and what the next command is going to do with it. Here's what I'd like to do. I'm going to run git process here for you. I want you to pick out the top 5 processes by their working set, or WS size. There. Can you grab the top 10? Top 5? Anything? No? How about if I scroll up a little so you can see which column is, in fact, you know what, I take it back. Dealing with columns and position is one of the things that makes Unix shells a little bit difficult to work with. I mean, for example, let's say I really did scroll up here like this, and you said, okay, the working set is in the 1, 2, 3, 4th column, and it's about, I don't know, 20, 30 characters over. Let's say you built a little script that was going to be based on that position. And so you were going to have it skip over and grab this number and do something and remember which ones were biggest. And then let's say some future version of Windows comes out and this column has moved to a different location. Well, now your scripts are hosed. And that's why PowerShell doesn't work that way. Now, another thing you need to be a little bit careful about are these column headers. These column headers are not necessarily property names. For example, there is no property called WS parenthesis K parenthesis. We need to start by looking at getMember. And with getMember, I can scroll through here and see that there is a property that contains the working set, and it's either working set or this WS alias property. Now, what would probably make your job a little bit easier in terms of picking out the top 5 or 10 or whatever is if I put them in order. So we're going to pipe get process to a command called sort object. And we're going to ask it to sort on the WS property. Now, those property names are not case sensitive. I could put lowercase. By default, it sorts in ascending order. Well, now it's relatively easy to pick out the 5 biggest ones because they're all at the end of the list. Now, this property parameter is positional, so people normally won't type it. And they'll usually, instead of typing the command sort object, they'll use the alias sort. So sort WS gives me the same results. If I put this in descending order, then my 5 or 10 biggest show up at the top of the list. So now I can just start counting. You know what? Heck with that. Counting sounds like manual labor. Let's pipe this to another command called select object and have it just select the first 5. That's exactly what I want. That's perfect. And I want to point out that that little path I took to get there, I ran get process first, and then I added the sort, and then I changed my mind and I added descending, and then I added select object, and I just kept hitting up arrow and adding to it to run it again. That's the exact way you should be constructing these multiple commandlet pipelines. Start with one command, add another. If you're not happy with it, modify it, then add another. So select object has an alias select, and that's what you'll see most people use, and so it'll look something like this. There's also a last. So let's say we took away the descending. We're going to keep the biggest ones at the bottom of the list now, ascending order, and we'll grab the last 5. Similar results, I mean the same data at the end of it, just different order, slightly different logical approach to it. You can do whatever you want to. And right there you've learned 2 new commands, sort object and select object. Now sort object is a little bit interesting. If you give it 2 properties, it'll sort by the first property first and then by the second whenever the first property is the same. So in this case, I might have multiple services running as the same name, and I do, SVAC host, service host. There's several processes with that. So when it runs into the same name, it'll sort them within that by working set. You have to pick ascending or descending for both. You can't sort ascending by name and then descending by working set. It's just beyond its capability. So you can see here that I've got several service hosts, and in their working set column, they are sorted by that working set within the name. So you can do that too. Lots of fun stuff. Select object is actually even more interesting than it looks. In addition to just grabbing, let's say, I'll go back to just sorting on the WS in descending order. I can grab the first 5, but I can also grab particular properties. So say I really just want the name. There I go. So this business of picking the first 5 or last 5 or whatever else, there's not any intelligence to that. It's not grabbing them based on anything other than their position within the list. Their position within the list was important because I sorted them first. If I hadn't sorted them first, I think they come out in alphabetic order by default, so I would have just been grabbing the first 5 based on alphabetical order. Select minus first has no intelligence. It's not looking at any criteria. It's just grabbing that hunk off the top of the list. The property parameter, if you choose to use that, can accept a comma-separated list. Since I'm looking for working set, it might make sense to add that. And this is when you're probably going to notice that the default formatting with PowerShell can be a little bit ugly. Anytime you give it 4 or fewer properties, let's just go ahead and add a couple more, it's going to try and use a table. If you add a 5th property, that's going to kick it over to a list. So that's the difference between those. And when it uses a table, it tries to fill the width of the PowerShell window. And that's why there's all that blank space in between those things. Now that is totally something that we can address. We're just not going to get to it for a couple more nuggets, but we will get into controlling that visual display. Right now, we're just dealing with the basic data. You do need to be a little bit careful about this. Oops, almost made a mistake. Select property, name, comma, WS, VM, PM. Now, this property parameter is positional, meaning I don't actually have to type minus property, so long as my property list goes into the first position. Now, over here, I put minus first, and that pushed this to the second position, so I needed to type minus property. But here, since I'm just doing the property, I can get away with that. And then I'm going to do this. And I want you to look at that and think real carefully about it. In fact, pause this for a second if you want to, and tell me whether or not that is actually going to work. If I hit enter, I don't get an error message, but think about what I asked it to do. I'm asking it to sort based on the CPU. But the only thing I included was the name, the working set, the virtual memory, and the paged memory. You got to think about what's in the pipeline at each stage. Remember, you need to be able to put your finger on the pipe and tell me what's actually in each section of the pipeline. And if you don't know, back off a command. If I pipe this to get member, you can see that select object is actually throwing away my original system.diagnostics.process object, and it's created a new one called a selected system.diagnostics.process, and it doesn't have all the properties of the object that was produced by getProcess. It only has the properties I specified. There's no way I could sort by CPU because this doesn't have a CPU property. PowerShell, however, is completely willing to just ignore that fact, run the command anyway, and not do any work. And that can get a little confusing, and I'll show you why it can get confusing also. I have a deliberate typo there. Look at how I spelled name, N-M-A-E. And you're thinking, well, that doesn't exist, so it's going to give you an error. It is not going to give you an error message. It's going to say, hey, you wanted me to include the property N-M-A-E. Well, there is no such thing, so let's pretend it's empty, and I'll just put it there and keep going. That can get really, really frustrating, not getting an error out of it. And you've got to be aware of that. When you get something blank like that, it's probably because you typoed something. Had you typed it right, there'd be data there. And that's why PowerShell won't yell at me about trying to sort on the CPU. It's going to see that there is no CPU and just kind of not do anything useful. You'll notice these are not in any particular order now. Because I sorted them on something that was non-existent, it's just kind of, whatever order they came out in, dude. They might be sorted by ID or something like that. It's hard to tell because I've got nothing to work with. No, see, they're just not sorted by anything because I asked it to sort on a non-existent property. So you do need to be really careful with both the logic of what you're asking the shell to do and be careful about the exact typing that you're doing to get the shell to get you there. Let's switch over to services for our next example. Get service, group object, property, status. Now again, as with most of these object commands, the minus property parameter is positional. You can just put that first. And there's an alias that's just group. And that's what you'll see most people type. And what this is going to do is go through and put each service into a separate group based on the property I told it to. And so there are 91 stopped services and 60 running services. So that's kind of fun to play with. Here's another cool thing you can do. Get process, measure object. Now in this case, I want to measure the working set. And I want you to give me the max and the min and the average and the sum of that property. So it's going to add up, and it's going to tell me I have 34 processes. The biggest amount of working set is this one. The smallest amount of working set is that. The total working set used by all of them is this. And each one's average working set is that much. Now here's where we can start getting into the crazy stuff. There is an alias measure. So instead of measure object, folks will start to truncate these. Max and min are pretty straightforward. You're going to look at that and know what they meant. Don't do this. There is no parameter called AVG, right? Max and min are not abbreviations. They're truncations of maximum and minimum. AVG is not a truncation of average. I could do this because that is a truncation of average and it'll work. You throw AVG in here and finally PowerShell will yell at us, I didn't find a parameter called AVG. What are you talking about? So we'll put average, and this is why tab completion is your friend. If you just type that much and hit enter or tab, now here in version 2, it's also going to wipe out the rest of the command line. I hate that, but that works. So measuring is another fun thing that you can do with these objects. There's actually, let's run a get command. Show me all the commands that use the word object as their noun. Now you've seen compare object. I've just shown you group and measure object. You've also seen select and sort. We're going to look at where and for each in a couple of upcoming nuggets. But these are all the commands that are designed to work with all kinds of objects. They can sort and select and measure anything. And so these are our generic commands. And you can see how they work really well together in the pipeline. Let's go back to that previous example I had where I was pulling out processes. Here we go. Sort my working set. Show me the first 5. And rather than showing me any particular property, I now want you to measure the working set and just show me the sum and the average. Now the resulting object will still have the maximum and minimum properties there, but they're not filled in because I didn't ask it to calculate those values. So you can see how this whole pipeline-y thing really starts to become kind of interesting and cool. Getting a bunch of stuff from here, piping it to there, it's sorting them, sending the sorted output here, it's grabbing the first 5. Now because I did not ask it to select a particular set of properties, it's going to pass along the entire object that was produced by getProcess and then sorted. So that goes to here, and it's got a working set property. At the end of this, though, my process objects are gone. Instead, I have this measurement object. And if you don't believe me, you can take that command and pipe it to getMember, and it'll show you that at this point in the pipeline, right here, what we had was a Microsoft.PowerShell generic measure info, and it has properties called average, count, maximum, minimum, property, and sum, which is exactly what was displayed right there. So I no longer have a process object at all by this point in the pipeline because measure object consumed those process objects, and then it spit out a different kind of object to be displayed on the screen. So if I did something like this, what do you think is in results.txt? It's exactly what would have appeared on the screen from that point in the pipeline. And that's what you got to be really, really just always thinking about, is what's in the pipeline at this exact point, because that's going to decide what the next command actually does. Not keeping track of that is a real easy way to just get yourself messed up. Now I want to do one more thing, and I'm hoping you remember back to nugget number 7 when we talked about hash tables. Let's take a look at the get process command, and you'll notice that, well, see, this is a little bit strange. Let's do this instead. Let's do select property star, meaning give me all properties, but just give me the first one, because there's too many properties to make a table out of, so it's going to make a list. I only wanted the first one because I don't want the list to run on forever. If you look at values like working set, they're pretty large numbers. You know, we get into max working set, we get into paged memory size, virtual memory size. I'm guessing those are all bytes. But when you look at the default output of this, we're not getting bytes. There's something going on under the hood that for the default output of get process, we're getting these kind of fancy column headers, and it's clearly doing some math. It's turning the working set into kilobytes, I guess, turning the VM into, I suppose that's megabytes. So I want to show you how you can actually manipulate that process and do it yourself. Let's clear the screen. We're going to run get process. I'm going to go to select object, and to try and keep things really, really clear here, I'm going to use the full syntax. No aliases, named parameters, not positional. Property. Normally, property takes a comma-separated list, right? Name, ID, VM, PM, CPU, and so on. I'm just going to replace one of these with a hash table. Now you will notice, if I move my cursor away, that that hash table is still within a comma-separated list. I'm also going to replace PM with a hash table. Now these hash tables are empty, but I'm going to populate them with some information. Select object is designed to look for hash tables in the property list, and when it finds one, it needs that hash table to be very specifically constructed. It wants a key called name, which is going to contain a string as its value, and then it wants a key called expression, which will accept a script block, which is inside another pair of curly brackets. Instead of name, you could also choose to use label. You have to use these keys, name or label, and expression, because the command is hard-coded to look for those. If you don't use those, it won't know what you're trying to do. So let's fill in some information here. For this first new column, because that's what I'm making here, is a new property, I'm going to call it VM in megabytes. Actually, that's the, well, you know, let's do that. I want MB. So here's what I'm going to do. I'm going to take $_. $_ actually represents whatever was piped into the select object command. Remember, select object is designed to be generic. It's designed to work with many different things. Select object doesn't know up front that this is a process, so it can't call it like process. It doesn't know that that's what it is. $_ is the difference. $_ is just a generic. It's a fill in the blank. Literally, it's a little blank. I'm going to grab the VM property of whatever was piped in and divide it by 1 megabyte. PowerShell actually understands KB, MB, GB, TB. I don't think it understands petabyte. I don't know. We'll test that in a minute maybe. So I'm going to do the same thing over here. This is going to be, what did I say I wanted to do? PM? We'll do that in megabytes as well. And you don't have to put these spaces in here. I just think it makes it easier to read. $_ PM divided by 1 megabyte. Hit enter. Now I had 5 properties there, so it displayed a list. I'm going to take CPU off to make it 4 properties so I get a table, just because it fits better on the screen. You can see it used the labels I specified for the column headers, And it kind of just, ugh, the numbers are ugly because of the decimal points. No problem. Up arrow. Here's a trick. Make it be an integer. So the as operator is going to take a value on the left, and it's going to take a data type in square brackets on the right, and it's going to try and turn the value into that data type. An integer is a whole number with no fractional component. So I want you to look at one of these. Just think of these last two processes on the screen here. You'll see this is 114.4, and here's one, 67.9 for task host. So task host went to 68, so it rounded up. And this last one, its memory may have changed. So it does actually round it based on the rules. 0.4 gets rounded down, 0.5 gets rounded up. So I did a pretty neat thing there. Let's add CPU back to the list. So I get 5, so that forces me into a list again. Now I need to show you some variations. You don't have to type out expression. You could just type E. You don't have to type out label. You could just type L. Got to be careful though, because that's going to look like the number 1. That's a 1. See how the roof on the 1 is kind of slanted? You got to be real careful with the lowercase l. Again, expression can just be E, and then name can be N. I really try to stay away from L just because it looks like a 1, just so you know. So there we go. That also worked. Where did I learn this? Where did I find out that you could do this? I looked in the help. I read the examples. You should take like a commandlet every day and just read the examples, because everything the commandlet can do is probably in the examples someplace, including this whole business with using this hash table structure to construct a new property. Let's talk about common gotchas when people do this. They'll do that, and PowerShell will freak out. And what they've done here is they've tried to do 2 custom properties, which is fine, but they've forgotten that each one of these is an item in a comma-separated list. Now, I like to do this. I'm going to have to type this from scratch. Get process, select object. Now, I'm going to go a little overboard just to kind of really emphasize what I'm doing. ID, name, @. Name equals PM in megabytes. Expression equals there's the end of my expression, the end of my hash table, and the end of my command. So PowerShell will let you hit enter after a comma, after a semicolon. It'll also let you do it within any construct that has openings and closings, like curly brackets. So if you want to, you can kind of format these a little different. And some folks find this broken out formatting to be an easier way to kind of see exactly what's happening, because the name and the expression are now on separate lines. So it's a little bit more obvious that they're separated. Of course, once you get good at the shell, you're going to start jamming this all into one line like I did here. And your brain will start deconstructing. I realize right now it's just a big crookedy punctuation-filled mess. But your brain will start getting good at breaking that down, and eventually you'll be fine. I can combine this with first 5. And I'm only doing that so that the output is short enough to leave the command on the screen at the same time. Now look, I know this whole hash table thing with the @ sign and the curly brackets might right now be making your eyes kind of cross a little bit, but trust me, this technique is going to get used multiple different times in multiple different places. It is worth the investment for you to learn how to do these. In fact, I want you to stop watching right now. Quit it. You're done with instruction for the day. I want you to open up a copy of PowerShell, and I want you to practice this. I want you to practice making these custom columns yourself, because it is an incredibly important skill set. And I want to make sure you've got this under your belt before we go any further. Though, let's switch over here to Windows 8 real quick too, because it occurs to me there is one more thing I need to show you. I'm going to have to type this whole thing again. Get process, select object, minus property, name, ID, @ sign, name equals VM. Let me make this font size a little bigger. I don't know, maybe you're young and can read that, but I can't. Let's go up to, I like console is better. That all still going to fit on the screen? It's too long, but I'll fix that in a second. There we go. Okay, yeah, bigger font, that's much better. All right, so name equals VM in megabytes. Expression equals $_ dot. Take the original VM, divide it by 1 megabyte, cast it as an integer so it rounds it up, and we're just going to take the first 5 so that the output fits on the screen. It's the same thing you just saw in version 2 of PowerShell. The difference in version 3 is that instead of $_, you can do $PS item. Same thing. You have to be on version 3 for that to work, but you're going to see people do it, and so I want you to know that version 3 introduced that. Just about any place you see $_, you can use $PS item instead. So now you can stop watching the video and go practice this. In this nugget, we continued to work with the PowerShell pipeline. I showed you some of the generic commands that PowerShell uses to sort, select, measure, and group objects. Keeping in mind that select really has a couple of distinct capabilities, it can pick out a set of properties that you want to see, which is actually modifying the object that's in the pipeline to just include those properties, or it can grab the first and last of whatever happens to be in the pipeline, and when it does that and not this, then it's the original object that's output. And you know what? That's really what this was all about. Thinking about what's in the pipeline at each stage, thinking about what each command is doing, and remembering that your good buddy getMember is always there to tell you what's in the pipeline at that point so that you can avoid those common mistakes that newcomers tend to get tripped up by. I hope this has been informative for you, and I'd like to thank you for viewing.